Hello everyone, welcome to my next tutorial part of the BDF software. In this tutorial we will be discuss related to the optimization of any molecules that you can do in the BDF software. So who is new in this tutorial part? I want to introduce myself. I'm Sahil Verma working as application engineer in the Impulse Technology. And please visit my previous tutorial so you can understand how we can use softwares. In this tutorial, we will directly discuss about the optimization and how you can do optimization in the BDF software. It's about the company and number of the university which is uses different softwares and our company that have partnership with AJW, Nano Academy Technology and Fluxing. And AJW parent company of the BDF software and we have the different products. We will be focusing on optimization, how you can optimize your structure in the BDF software. So like if you want to optimize your geometry, so that help to find the most stable structures by adjusting the atomic position to minimize the total energy. Minimum energy structures provide the equilibrium structures where the molecules has minimum total energy and maximum stability you can find. Zero force or gradient optimizations continue until force on all atoms are nearly zero, indicating a stable structures. Optimize both bond length and angles. Best for the further calculation, like first you can optimize your structures, then you can do various properties like frequency, HOMO-LUMO, TDFT, nuclear magnetic regions, UV visual spectroscopy, and spin orbit coupling, non-adiabatic coupling. Different properties you can calculate. Convergence to the stable structures. That process iterate until convergence is reached, being the most stable molecular structure. But basically that outcome you can see lowest energy, stable molecule geometry and reliable structure for the further analysis. So in this tutorial part, I will take one of the molecule structures. You can take any molecule structure. You can also create your molecule structure. Who has not seen it my previous video, they can see and they can understand how you can take molecules. If you want to import online molecules, so you can also import your online material. If you want to create your molecules, you can create. So now I'm going to open Device Studio where you can do. I have already discussed BDF engine that have supported in the Linux. So all the calculations will run on that Linux system, but it is a GUI where you can connect your systems and you can create your structures. You can run in here, but all the calculations will run on that Linux. So you can import your result from the Linux system. So I will show how you can do. If you see my previous video, so you can understand how we can do different calculations. So it is a 4 tutorial related to the video software. So now I'm going to open Device Studio. Now we can open Device Studio. We can create any other new project, give any other name Optimization Tutorial. In a previous session, we have discussed how you can create the new project. If you have the existing projects or examples, you can open from these tabs. You can save your project. If you want to create device for the crystals, you can add whole periodic table are given. If you want to create the crystals for the molecules, you can use different tabs like this. And if you want to import local, you can see different format that have supported in here and different materials you can import amorphous, crystallines. Same given for the 1D materials, 2D materials, 3D and organic materials. And if you want to import your online materials, you can directly import from these tabs. I'm just going to show how you can take one of the molecules and how you can optimize the structures. So if you want to take online, you can take. If you want to create, you can create from these tabs. Like this, you can see different ring fragments, cyclopentane, cyclopropane, and benzene, coronene. And when you move towards the molecule 2D, you can also create by your own selves your structures. Predictables are given. You can create. So it totally depends on the users, which type of molecules they want and how you want to create. So you can create. You can also add any other different molecules. It is just a simple carbon that have imported. You can delete. So I'm going to consider one of the molecule structures. Like you can consider in here that pentalene. I will show how you can optimize this pentalene structure. You can click on the apply data. Same process you can apply, and then you can move toward the simulator. You can see different softwares given in here: Nanodecal, Nanoskim, Rescue, BDF, MOMAP, and they provide the GUI of the different softwares. You can focus on this BDF, and you can see basic settings, job title, file name, single point energy, optimizations, frequency, optimizations plus frequency, TDFT spin orbit coupling. We have already saw this type of examples in MRIRC. So you can select in here that optimizations, Hamiltonians, different Hamiltonians giving relativistics or non-relativistics method that have supported in here, different functional groups, Jude dispersion correction, van der Waals interaction is included in here. Restricted, that means closed cell system calculation or open cell system calculations you can do in here. Alpha beta, that we have discussed in a previous video. Basics, and that set that you can select in here. Charge, depend on the users. Multiplicity, electrons are paired or unpaired. If you want to include salvation effects, you can include. If you want to ignore the symmetry, you can ignore initial base atoms or different things that are given. How much your accept calculation will iterate, so that given in a, it is 100 times that will iterate. Convergence threshold, very tight, default. So you can select same for the DFT, but it be given in the ultra coarse, medium. So if for that accuracy you can do in level, you can shift damping effects, MPC. So you can enhance your calculations in a different orbitals. You can optimize your geometry, like we have selected the BDF software, optimize to minimal or transition state. When you select that a different excitant state like TDFT or different things, so you can also see different tabs in here. How much that iterate your optimization setting that I've given. Trust step size ratio, recalculate Hessian's calculation, and that script has been created in here. You can see. You can generate your file. Before of this, you can connect your systems with the BDF engines to the job manager where your simulations file will run. Then you can click on this and you can run your project. You can see at the bottom side in the job managers, it is a queue form, but it is not running your program. So before of this, you can open putty and types in the terminal ls for the list. Then you can add directory cd, click the tabs and molecules you can see in here. Again, you can check list as Alex. You can click. Then you can add your directory with the BDF. click enter. Then you can run your program as BDF dot inputs. You can type that command BDF dot out and click enter. Now calculation has been started. Now you can close this session, and when you click on the Win SCP, with the help of Win SCP, you can collect your results. You can see that project copy, and here you have created this project, so you can upload your result, paste. Then you can disconnect with this, and you can check your results. BDF.output files. It is the total energy, so it is the most stable structure you can find. Atomic numbers, atomic symbols, you can see in here. Charge numbers for the every atom. Length bonds, you can check in here. If you want to do further calculations, so you can also apply their data. You can click on the large view, and summary you can check. Molecular orbital representations, we have selected the restricted, so only closed cell calculations you can see in here. We have discussed in the previous video, but we can also discuss short terms like virtual. That means some of the empty space in the orbital available, and it is that energy. It is occupied, and you can see in the minus. So that means it is a not any empty space available in the orbitals, and you can check in your homologographs in the electron volts. You can also change units, and it is a optimization results, optimization steps and their calculations. Like at the top sides, you can see the total energy. It is a optimization step which is completed at 4 steps. Like you can check in the step numbers, and total energy decreases during the optimization steps. When increases, decreasing in energy, that indicate the molecule is moving towards a lower energy, and that become more stable geometry. And at this RMS force, and the software shows converged in air, and it represent overall residue force acting on the atom during the optimizations, and the value should become more small. If the value is small, so it is converts, and the force convergence criteria has been satisfied in here. And when you move toward the maximum force, it represents the largest remaining force on any individual atoms. It also decreases. It is also mass converged, which means there is no significant remaining force that would cause a major change in the molecular geometry. And when you move toward the Hermes displacement, it indicates average movement of the atom between two connecting optimization steps. This value has very small and mass converged at this value. This means atomic positions is becoming essentially stable. Maximum displacement value you can see here 0.000649. This represents the largest displacement of any atom during the final optimization steps. It is also converged, indicate the molecular geometry is no longer changing significantly. So overall, it is a conclusion that BDM optimization successfully converged. The molecule has reached a geometry where the energy is low, forces are very small, and atomic positions are nearly stable. And consider these optimizations, you can do further calculations. And most important thing, optimization conversion alone does not prove that structure is true minimum. Frequency calculation should be perform afterward. A true minimum normally has imaginary frequency. So after this we will calculate optimizations plus frequency, but in the next tutorial you can see. And when you click on the BDF XCF modern files, same you can check different molecular orbital and their representations, irreducible representation, you can see occupy and virtual we have already discussed, and it is energy, transparency, and you click, you can collect your results in the image form. Axis you can change in here. So you can see how we can optimize different molecule structure. It is a simple examples, but you can consider any one of the examples and you can take one of the molecules and follow the same steps and you can optimize your structures. So who has not seen it my previous video, please check out the playlist of the video. Not only the video, we have the different software, so you can visit. Now we are going to end here my tutorial. If you have any query related to this, you can comment, and my email also attached in the video. So thank you very much, and please like and share and subscribe my channel.